Alright, so in this section we're going to be taking a look at a different type of ion that can be involved in ionic bonding. And just to give you a reference, in the previous section, or from the previous sections that we looked at, okay, we were able to look at bonding in terms of monoatomic or monatomic ions, right? Which were ions formed from single atoms. So for example, we looked at sodium, plus we looked at the oxide, we looked at aluminum, etc. They were all ions formed from a single atom. Now we're going to take a look at what are known as polyatomic ions. And what a polyatomic ion is, or what polyatomic ions are, they are collections of atoms that possess or that have an overall charge. Alright, so here it's not just a single atom that has a charge, it's actually a collection of atoms that possess an overall charge. And these atoms are going to be all nonmetals. And the vast majority of these polyatomic ions are mostly going to be negative, so they're mostly going to be anions, with the exception of one important cation, and that's NH4 with a positive charge, which is called the ammonium. So we're going to take a look at some of these polyatomic ions. There are several of them that you need to know that you're going to be seeing way more frequently than others. The polyatomic ions, you actually see them quite frequently. They are in lots of very common substances. So for instance, if you had a plaster cast that's made up of this compound here, this ionic compound called calcium sulfate, and it contains the sulfate anion. Fertilizer contains ammonium nitrate, which actually is made up of the ammonium ion and the nitrate ion. And then something that you find in your kitchen, for instance, you have this compound, NaHCO3, which is sodium bicarbonate, which is also known as just simply baking soda. Right, and this is made up of the sodium ion, and you have the bicarbonate ion, right? So this bicarbonate here is the polyatomic ion that we're looking at. Alright, so we'll take a look at some of the common polyatomic ions that you are going to encounter and the ones that you need to know. Alright, so the ones that you need to know, and this is taken from table 6.8 from your textbook, you don't need to know the entire table. Okay, there's several of these that we're not going to see, whereas there are others that we're going to see way more frequently. And the ones that I've put a little tick mark next to are the ones that you need to know. Let me just highlight these, maybe that'll be a little bit easier to identify them. Alright, so starting on this list here, we have hydroxide, which has an OH minus, ammonium, which is NH4 with a positive charge. We have nitrate, which is NO3 with a negative charge, nitrite, NO2 with a negative charge. And then you can work your way down to see the ones on this list that you need to know. In the next half of the table, we have several here that you need to know as well. Sulfate, we have sulfite, we have phosphate, and we have phosphite. All right, so those are going to be the most common ones that you need to commit to memory. All right, so the quicker you get that into your head, the better it's going to be in the long run. So knowing those polyatomic ions and recognizing them is the first step, and then using them for the nomenclature thing that we talked about in the previous section. So for example, if you're given the name for a compound magnesium nitrate, right, we need to write the formula for this. So we've already seen magnesium before, right? Magnesium is Mg, and we know that magnesium is in group 2, so its charge is always going to be positive 2. Now you need to know nitrate, right? This is a polyatomic ion. You have to be able to recognize the name and the formula together with the charge. And nitrate is NO3 with a -1 charge. When you put these two ions together, you're going to put them together in the exact same way like you did previously. The cation goes first, and then the anion goes second, NO3-. Now, because you have a polyatomic ion, all right, it introduces a little bit of a conundrum here. So if you do your cross-charge method, the shortcut, right, then we saw the 1 here for the nitrate becomes a subscript on the magnesium, and then the 2 on the magnesium should become the subscript on the nitrate. So where do you put the 2 to illustrate that we have 2 nitrates? Well, the way that we do that is you have to put your polyatomic in a pair of parentheses, and then the 2 goes on the outside of the parenthesis. All right, so we end up with Mg NO3 twice, not Mg NO3 2, right? There's no such thing. And then similarly, not Mg2 NO3. There's no such thing. That's completely wrong. All right, so we're going to use parentheses here, and you only use them when you have more than one. Of the polyatomic ion in the formula. If you only have one polyatomic ion in it, then you don't need the parenthesis. All right, let's take a look at another example. Here you're given the name for aluminum bicarbonate. All right, so aluminum, Al, aluminum's in group 3, so it's always +3. And then your bicarbonate, that's another name for hydrogen carbonate, which is HCO3 with a -1 charge. All right, so when you put these together, the metal or the cation goes first, and then you have your polyatomic that goes second. I like to just put that in parentheses right away. So visually I can see, my eyes are going to tell me that I'm going to treat that polyatomic as an entity, as a collection. The 1 here becomes a subscript on the aluminum, and then the 3 on the aluminum becomes a subscript now on the outside of the bicarbonate. So we end up with Al HCO3 3 times, and that's your formula for aluminum bicarbonate. All right, so let's take a look at going in the other direction. Here you're now given the formula, and you have to come up with the name. All right, and we're going to approach this the exact same way like we've done ionic nomenclature before. We're going to name it as we see it. So Ca is the metal. We're going to name that first. That's calcium. And then you have to recognize now, right? So you need to know that NO3, this thing here, is simply nitrate. And that's all that it is. This compound is calcium nitrate. Right? Similarly, if we had something like NH4, SO4, right? So that may look ultra complicated, all right? But you have to recognize, and what's going to be your clue in some cases is that you're going to see a pair of parentheses in a formula, and if you see that, then that tells you right away that you're dealing with a polyatomic ion. So in this case, all right, you have the NH4, and you have to recognize that as ammonium, right? And that's ammonium, not ammonia, right? They're very different things. So NH4 is ammonium, and then you have to recognize this SO4 as also sulfate, right? So that's ammonium sulfate. Often what I see with students when they look at nomenclature initially, they're tempted to name or try to name every single atom in there. All right, and that's what I do not want you to do. So for instance, you're not going to name this as nitrogen, hydride, sulfide, oxide, right? That's completely wrong. Okay, you have to recognize, you must recognize the polyatomic ions, right? And the only way to recognize them is to commit them to memory. And you can use flashcards to help you do that, or whatever your strategy is. You have to get those polyatomic ions down so that you can quickly see them and locate them, identify them in a chemical formula.